So on this side, it's kind of the same thing. We're finding the distance between 2 points, or the length of this like diagonal line. But this way we're actually going to use Pythagorean Theorem. Do you remember the Pythagorean Theorem from 8th grade? Pythagorean Theorem is a squared plus b squared equals c squared. Does that sound familiar? Okay. So this formula, Pythagorean Theorem, was used for right triangles. So right triangles that look like this, right? And in Pythagorean Theorem, this A and B, and then the hypotenuse is C, and you plugged in these lengths to find the length of the hypotenuse or the legs, and that's what we're using. And you might be thinking, well, how does that relate to this? That's not a triangle. So what we're going to do is actually make a triangle. So from this diagonal line, just make a right triangle, like draw it out. And now that we have a right triangle, we can use Pythagorean Theorem to find the length of the hypotenuse, this diagonal line. So the length of this here, 1, 2, 3 units. And the length of this, 1, 2, 3, 4, 5 units. And then we're going to find C, the hypotenuse. So a squared plus b squared equals c squared. So we get 3 squared plus 5 squared equals c squared. And then c will be the length of that diagonal line. So 3 squared, 3 times 3 is 9. 5 squared would be 25. 34 equals c squared, and then take the square root of both sides, and the square root of 34 is 5.83. So c is 5.83-ish. So that's how we do that. So on this page, I'm going to do like the first 3 with you here, and then have you do these on your own. And then in this portion, I'll do the first 2, and then have you do the last 2 on your own before you turn it in. So we'll do this one together, we'll do these 2 together, and then I'll have you start doing them on your own. So then this one here, number 2, drawing out the right triangle like this. Let's see, so this is 1 unit. And then this here, 1, 2, 3, 4, 5, 6, 7, 8. And then the hypotenuse would be c. So a squared plus b squared equals c squared. 1 squared plus 8 squared equals c squared. Square root of both sides, and then c equals square root of 65 is 8.06. Okay, number 3 we're going to do together as well. The hardest part for this actually is drawing the right triangle. I notice people get stuck with drawing the right triangle. So for number 3, try to draw your own right triangle before I show you what mine would look like. Okay, so here's what my right triangle would look like. If you drew yours this way, that would be fine as well. It's going to give you the same numbers. But I'm going to stick with this one here. And this one, 1, 2, 3, 4 units here. And 1, 2, 3, 4, 5, 6 units here. And then a squared plus b squared equals c squared. So we get 4 squared plus 6 squared equals c squared. Gives me 52, square root is square root, I'm going to get this number. Okay. So I'm going to have you do these three on your own in a second. But before I have you just like go off and do these, I'm going to show you this bottom portion too that I'm going to have you do as well. So it says, now use distance formula to find the distance between these 2 points here. This is what you're actually, so you're going to take a break from this. I'm going to have you do that on your own in a second, but before I have you go off and do that, this portion down here, I'm going to do two of these with you, and then I'll have you do these two on your own. So this here using distance formula is what you were doing on the other page. So you label this x1, y1, x2, y2. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. And then you plug your numbers in. You could technically graph these points and do it with the Pythagorean Theorem, but sometimes they give you decimals or really large numbers that wouldn't make sense for you to graph it like that, so that's why it's important to know both ways. Then number 6, same idea, x1, y1, x2, y2. For this one, I'm not going to rewrite this equation again, I'm just going to use it as so x2 minus x1, 0 minus 10 squared plus y2 minus y1, like that. Okay, that's all.